All right, so today we're going to talk about electron configurations and electron orbital diagrams. It can get really messy to draw atoms with all these orbitals with spheres and P's and just start drawing them bigger and bigger. It's going to get really big and messy all over your page. And so we need a simpler way to represent where the electrons are located in an atom. And so that's where these lessons come in. So we're going to learn a little bit about electron orbital diagrams and electron configuration. Okay, so you don't want to make a lot of drawings showing electrons because your drawings are going to get really messy and large. So we've come up with a really simple way to represent the location of electrons for every element on the periodic table, and that is known as the electron configuration. So the way we write out an electron configuration is we start with the number in the front. This first number represents the shell or the distance from the nucleus. The second symbol here represents the type of orbital. So this is the s orbital. And then this superscripted number is how many electrons are in that orbital. Now hydrogen only has one electron. That one electron is located in the first shell in the s orbital, and it's one electron. So we would say that its electron configuration is 1s1. So first one is the shell, second one is the orbital type, and the third one is the number of electrons in that orbital. When we move to helium, it has two electrons and they're both located in the 1s orbital. Now, when we talk about carbon, carbon has 6 electrons, and those 6 electrons are located in this electron configuration you see here. 2 of them are in the 1s, so we say it's 1s2. Then 2 of them are located in the 2s, so we say it's 2s2. And then we add 2 electrons to the p orbitals, and so we say it's 2p2. In the end, if you add up the superscripted numbers here, 2 plus 2 plus 2 should equal 6, which is how many electrons carbon has. So we would say the electron configuration for carbon is 1s2, 2s2, 2p2. Now calcium has 20 electrons, and what we're going to do is build our way up to figure out where all 20 are located. So the first 2 are in the 1s2. The second 2 are in the 2s2. Now remember that the p orbital can hold up to 6, so it's 2p6. Now, so that gets us to 10. Now we jump out to the third shell, the third energy level, and it's 3s2. And then, of course, the 3p can also hold 6, so we're going to add 6 there. And then there are 2 left over, and so those 2 are going to get bumped out to the fourth energy level, the fourth shell, and there's going to be 2 more located right there. So we would say that the electron configuration for calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. When you look at a periodic table, you can actually figure out exactly how many electrons are in that orbital by simply looking at its location. So the periodic table is actually designed to tell you where its electrons are. The first 2 columns here are your s orbitals. So that tells you how many electrons are located, and it's basically telling you where the last electron is located. So you can see that anybody in this first row is going to have 1 electron in its outermost s, and how many s's there are is simply how many rows down it is. So this element here would be the 5s orbital, and there'd be 1 electron in it. If you're in this column, the second column, there's going to be 2 electrons in that outermost s orbital. Now we're going to skip this zone right here. That's for a whole different discussion later on, and we're just going to jump over to the p orbitals. So we call these the p orbitals, and it'll tell you how many electrons are located there. Well, there's 1 in that one, there's 2, there's 3, 4, 5, and then other than helium here, which is kind of an oddball, everybody in this last column has a full p orbital with 6 electrons in it. When you need to add a new electron to that, we have to jump up a shell and go to the next level. So simply by looking at where they are in the periodic table, you'll actually know how many electrons are in the outermost orbital. So for this element right here, there are 3 electrons in the p orbital in the 4th row. All right, so let's figure out what the electron configuration of phosphorus is. So take a look at your periodic table and figure out where phosphorus is. All right, so I'm going to assume that you paused the video and you found where phosphorus is. And phosphorus is located right here. So there's phosphorus. So what is the electron configuration? Where the outermost electrons are? Well, simply what you're going to do is work your way down the periodic table. So see where my arrow is over here? You're going to say 1s2, that's the first row. Then you're going to go to the second row, and you're going to say 2s2. Then you're going to work your way over to the p's and say 2p6. Then you're going to work your way over to the third row and say 3s2. And then it's the third one in the p orbital, so 3p3. So again, we're going to go 1s2, that's for your first row, 2s2, that covers these two, 2p6 covers these guys, 3s2 covers these two, and 3p3 tells us it's the third one over in the third row of the p area of the periodic table. So we can talk about these orbital blocks. So this area of the periodic table is the S block. It tells you that the electrons are the outermost last electrons are located in s orbitals, and the row tells you which s orbital it is, how far from the nucleus it is. This area of the periodic table is known as the p block. It tells you that the last or outermost electrons are located in p orbitals and how many over you are. We also have this area over here called the D block, and that D block is also another type of orbital that we'll get into later, and it'll tell you how many are located there. Just counting over, there's 10 across that, up to 10 across that row. And then there's actually an F block that's located down here, and we don't really talk about the F block. In fact, even in advanced college chemistry classes like I took, we didn't ever really talk about the F block. But just realize that if there are electrons located down here, they are located in something known as F orbitals. Now there's another way to represent where the electrons are located. It's something known as an electron orbital diagram. And in an electron orbital diagram, what we're doing is representing the electrons by arrows. And so you'll see these arrows here. So we have a box, or it can be a line, and we label them 1s, 2s, 2p, and so forth. And the arrows represent where the electrons are located. So if you take a look at where aluminum is on the periodic table, aluminum's number 13, so there are 13 electrons. We got to represent where they are. So if we were writing out the electron configuration, we would say it's 1s2, and then it's 2s2. So you'll notice on here that in the box we've got 2 arrows. When 2 electrons are located in the same exact orbital or suborbital, we draw the arrow as up and down, and I'll show you why in the next video. And so we've got our arrows up and down, and then the 2s2, it's up and down. Now remember, there are 6 possible locations for electrons in the p orbitals. There's the x, the y, and the z. And each one of those can have 2 electrons. So we say that there are 3 suborbitals, so we may have 3 different boxes, and then each one can hold up to 2. So 1, 2, 3, 4, 5, 6. So we would say that this is 2p6. Then we go to the next energy shell, the 3s2. So we're going to put our 3s2. And then in the 3p, you'll notice that there's only 1 electron. So we just draw our 1 arrow here, and we would say this is 3p1. And the other 2 are empty because there are no electrons in them right now. It can hold up to 6, but there's only 1 electron, so we just draw the 1 arrow. You still draw the other boxes and show that they're empty because that actually can be important when talking about chemical bonding later on. Sometimes we draw them just straight across, and sometimes we stack them just to show the energy levels. And so if we were filling in aluminum, we would actually just fill it in as 1s2, so there's our arrows here. It's hard to draw arrows with this thing. And then we would draw our 2 arrows here because 2s is a little higher. And then our 2 p's are going to be up and down, up and down, up and down. We go to our 3s, up and down, and then finally our 3p, we just draw our 1 arrow right there. And so that is another way it can be represented. So it can be represented horizontally, or it can be represented somewhat vertically. And what you'll notice on here is that we're showing our s located right here, and we're showing our p's located right here. So up shows the amount of energy, and this shows basically moving across the periodic table.